Hello everyone and welcome to Love Math. In this video, we will be covering the second installment of the topic polynomials. So let's go ahead. So a recap. So we'll do a short recap of what we did in the part 1 of the polynomials. So we learned about the polynomial definition, what is a polynomial. We learned about the degree of the polynomial. We also learned about the types of polynomials based on the degree. And we also solved a simple polynomial, right? So in this video, we will be covering the zeros of a polynomial and we will be graphing or plotting a linear and a quadratic polynomial. Okay, so the first topic is solving a polynomial, a special case. All right, we already have solved a polynomial in the previous lecture, so you might have a little idea of how it is being done, right? So let's take one more example and see why is this case a special case. So consider the polynomial f of x equals x cubed minus 6x squared plus 11x minus 6. Now I want to solve this polynomial at x equals 1, x equals 2 and x equals 3. So in the previous lecture we only took one value of x and solved the polynomial, right? Here we have three values. So you will solve this polynomial three times, first with x equals 1, then x equals 2 and then x equals 3 independently. Let's see how it's done. So we'll find f of 1, f of 2 and f of 3. So f of 1 is replacing the x variable in the polynomial by 1 and solving the right hand side of the equation. We get 0. Next, now we replace x with 2. Here, so we have replaced the variable x in the polynomial f of x by 2 and we solve the right hand side of the equation. We get f of 2 equals 0. And the last case, x equals 3. So we replace x variable in the polynomial f of x by 3 and we solve the right hand side of the equation and we get 0 again. So what did you observe here? That when I substitute three different values of x in the polynomial, I get the same answer, and that is 0. This means something. So for x equals 1, 2, 3, we get f of x equals 0, right? So 1, 2 and 3 are called the zeros of the polynomial f of x. I repeat, so what are the zeros of the polynomial? The values of x such that when I substitute that variable x with that particular real number and I solve the right hand side of the equation, and if I get a 0, that means that value x is called the zero of the polynomial f of x. Easy? Let's go ahead. Find zeros of the polynomial. Okay, now we'll find the zeros of it. In the previous case, I already gave you three zeros, right? 1, 2 and 3. Now I want you to find those zeros. So definition: a real number alpha is a zero of the polynomial f of x if f of alpha equals 0. This simply means that if I replace the variable x by some real number alpha, and if I solve the right hand side of the equation, if I get 0, that means alpha is the zero of that polynomial. So, so the question is, find zeros of the polynomial g of x equals 3x minus 6. Alright, so this means that I have to find that value of x. So when replaced in the polynomial, I get g of x equals 0. Right? We just did it earlier. So we know that 3x minus 6 equals 0 because g of x equals 3 minus 6 and g of x equals 0. That means 3x minus 6 should be equal to 0. So in this, we find the value of x, which you know how to be. I assume you know what is algebra. So x equals 2. So this means that when I replace the variable x with 2, and if I solve the right hand side of the polynomial, I'll get a 0. Let's check. So g of 2 equals 3 into 2 minus 6. 6 minus 6 equals 0. So this proves that x equals 2 is the 0 of the polynomial 3x minus 6. Got it? Nice. So now we did two cases, right? First, we took the polynomial f of x equals x cubed minus 6x squared plus 11x minus 6, and also we yeah, and sorry. So we also saw that there are three different zeros: x equals 1, x equals 2, and x equals 3. Then in the second problem, we took on another polynomial g of x equals 3x minus 6, and we saw that it had only one zero, x equals 2. Why is that? Why does the first polynomial has three zeros and the second polynomial has only one zero? There is a reason behind it. So if you see the first polynomial f of x, you'll find that the degree of the polynomial f of x is 3, because x is raised to the power 3, which is the maximum of the entire polynomial. And for g of x, the degree of the polynomial g of x is 1, because x is raised to the power 1. Also, the degree of polynomial f of x is equal to the number of zeros that polynomial has, that is 3. Alright, so this means the degree of polynomial is equal to the number of zeros of that polynomial. F of x has a degree of 3, so it has 3 zeros, 1, 2, and 3. G of x has a degree of polynomial 1, so it has only one zero, x equals 2. Now let's do an example. How many zeros does the polynomial f of x equals x raised to 7 plus 5x raised to 4 minus 11x squared plus 50 have? So, what is the degree of this polynomial? You will see x is raised to the power 7, 4, and 2, but the maximum number is 7. That means the degree of this polynomial f of x is 7. And from the previous slide, we learned that the degree of polynomial is equal to the number of zeros that polynomial has. So therefore, f of x has 7 zeros. This means that there are 7 values of x which, when substituted in the polynomial and we solve the right hand side of it, we get f of that number equals 0. This is the real meaning of the zero of the polynomial. Let's go ahead. Now we'll see how to graph a linear polynomial and how does a linear polynomial look. So in the previous lecture, we did that linear polynomial is a polynomial having a degree 1. So let's take an example. F of x equals 4 by 3x minus 2. Here x is raised to the power 1. That means it is a linear polynomial, right? Now you can see I have divided the linear into line, L-I-N-E. So this means that when I plot this particular function on a graph, I'll get a straight line. Now at this point, I'm assuming that you know what rectangular coordinates are and how do you plot those points on a graph. So graph of a linear polynomial is a straight line. Let's see. So here you can see a graph with horizontal axis called the x-axis and the vertical axis called the y-axis. And you can see an inclined line passing through the x-axis and the y-axis, and the name of that line is y equals 4 by 3x minus 2. That line is called 4 by 3x minus 2. For example, like you have a name, I have a name, this channel has a name, Love Math. Similarly, this particular line has a name, 4 by 3x minus 2. Okay, so let's do an example. Let's plot a linear polynomial and see. So draw the graph f of x equals 2x minus 5. So here you know that the degree of polynomial is 1. That means it is a linear polynomial and hence we'll get a straight line. So 2x minus 5, if I input different values of x on the right hand side of the polynomial, I get different values of f of x, right? Like different inputs of x, different outputs of f of x. Let that output f of x be y. That means y equals 2x minus 5. Now assume any value of x, any real number ranging from minus infinity to plus infinity, anyone. Like suppose we take x equals 1 and then we solve for y. So substitute x with 1 and solve for y. So y equals minus 3. So we know that y equals minus 3 at x equals 1. So the rectangular coordinates x comma y is written as 1 comma minus 3 because x equals 1, and for that value of x we got y equals minus 3. Okay, here. Now let's take another case. Now why we are taking the another case? Because infinite number of lines can pass through one point. You must have done that in your previous grades. So for that, so we need a particular line, so that we need a minimum of 2 points. So let's assume another value of x, say x equals 0. 0 is a real number, so it's fine. And then solve for y. Substitute x with 0, so we get y equals minus 5. Therefore, y equals minus 5 at x equals 0. So the second rectangular coordinate which we got is 0 comma minus 5. So when we draw a smooth curve passing through these 2 points, we'll get a line, and that line is y equals 2x minus 5. And it looks like this. You can see the x-axis and the y-axis, and a blue inclined line which passes through the x and y. That line is called y equals 2x minus 5. And you can see the 2 points, 0 comma minus 5 is somewhere here, as you know, and 1 comma minus 3 is here. So the only line passing through these 2 points is y equals 2x minus 5. You can take more cases, x equals 1, x equals 2, 3, 4, 10, 100, whatever you want to take, you can take that value. I have taken 1 and 0 because that is easy to do the math, right? The math becomes easy when x is 1 and 0. So this is how you plot a linear polynomial on a graph. If you have any doubts, put it in the comment section below, or email to me. I will attach my email address in the description below. So now, graph of a quadratic polynomial. All right. So as we saw, the graph of a linear polynomial is a straight line. The graph of quadratic polynomial is not a straight line. It is a curve. We'll see what. So in the previous lecture, we did that the quadratic polynomial is a polynomial having a degree 2, right? So we took an example, x squared minus x minus 2. The degree of this polynomial is 2. So it's a quadratic polynomial, right? And when we plot this particular polynomial on a graph, we get a curved shape, and that shape is called a parabola, right? You have to remember this word. This is very important shape, and we'll do it all throughout the math syllabus. So please. So this parabola. Now, how does the parabola look? Now, parabola is a shape like we have rectangle, triangle, circle, pentagon, hexagon. These are closed shapes, right? So parabola is also a shape, but it's a curve and it's an open shape. Let's see what this. So this red curve is called a parabola, right? It is opening upwards, right? It's an open figure, and the name of this parabola is y equals x squared minus x minus 2. So you can clearly tell the difference between a linear polynomial and a quadratic polynomial, right? Linear polynomial is a straight line. Quadratic polynomial is a curve called parabola. So now let's example. Let's plot one of these. So draw the graph y equals x squared minus 2x minus 8, right? So now in the previous case, we took different values of x and we got different values of y. And then we plotted those points on the graph and we passed a smooth curve. The same concept applies here. Let's see. So x and y. We take different values of x ranging from minus 4, minus 3, minus 2, 1 is 1, 0, 1, 2, 3, 4, 5, 6. And for all these values, we get different values of y. Now you might have a question. Why did we take these many values of x for a quadratic polynomial and just 2 values of x for the linear polynomial? So this is a curve, right? So more points you take, more iterations you do, the more accurate the curve you can plot on the graph. Okay, a straight line needs only 2 points. You can just put your ruler and just draw a line through it. But for a curve, The more points you take, the more accurate your curve will look. All right. So here in the table, the first row is the input and the second row is the output. This means that when I substitute x with -4, I get y equals 16. So -4 and 16 is the first point, -3 and 7 is the second point, and so on, like this, right? So we got 8 or 9 points. So now so now after you plot those points on a graph and draw a smooth curve through it, you'll get this shape. This shape is called a parabola. And you can see I have marked different arrows of all the points that we had found in the previous slide. Like if you start from top left, you'll see -4, 16, -3, 7, -1 and 5, 0, -8, and so on. All right. Now, if you look the figure closely, you'll see the bottom point 1 and -9. That point of the parabola is called a vertex. So what is a vertex? So vertex is a point on the parabola from which, if we pass a vertical line, as it is shown in the figure, a dashed vertical line is passing through that point 1 and -9. So if we pass a vertical line through it such that it divides the parabola into two equal halves, you can see the vertical line which is passing through 1 and -9 divides the left and the right side of the parabola into two equal halves. So that intersection between the vertical line and the point on the parabola is called the vertex. And for this parabola, we have vertex 1 and -9. Got it? Great. So from that graph, we make some key observations. What are those? First, now our polynomial was x squared minus 2x minus 8. So here you can see that the coefficient of x squared is 1. Only x squared. We're not talking about x or minus 8. Only the coefficient of x squared, that is 1, which is a positive real number, right? So if the coefficient of x squared is positive, 1 in this case, the parabola will open upwards, as we have the graph on the right hand side of the screen. Here, suppose we had a coefficient of x squared as -1, then our parabola would open downwards. You can imagine that. I'll give you some examples, right? I'll give you some examples so you can practice on your own, draw the graphs and make the key observations. Second observation we make is zeros cut through x-axis. Now what does this mean? So for the polynomial y equals x squared minus 2x minus 8 has two zeros. Why? Because the degree of the polynomial is 2. So we'll have two zeros, right? And those two zeros are x equals 2 and x equals 4. We will learn how to factorize this polynomial and how to find the videos in the coming lectures. So stay tuned. So you can see when I replace x with -2, I get y equals 0. And when I replace x with 4, I get y equals 0. So we have two rectangular coordinates, -2 and 0 and 4 and 0. Now if you see the right hand side of the screen which I have drawn the parabola, -2, 0 and 4, 0 are these 2 points on the orange arrows which I have marked. Now you can see these 2 points are on the x-axis. So what does this mean? So the key observation we make here is the number of zeros that any polynomial has. In this case we have two zeros. That means the curve of that polynomial will cut twice with the x-axis. I repeat, this polynomial has two zeros. So this curve polynomial, this parabola will cut the x-axis exactly two times, as you can see, once at -2, 0, sorry, and second at 4, 0. Now, if the polynomial has only one zero, like a linear polynomial, as you saw, that in that case the line passed only once through the x-axis. That means if the curve of the polynomial passes just once through the x-axis, that means it has only one zero. Now suppose we had a parabola such that it does not cross x-axis at all. It is like above the x-axis or below the x-axis completely. This means that that parabola does not have any real zeros. We'll do some examples. I will give you some practice problems to do and you'll see. The third is x square minus 2x minus 8. If we compare this polynomial with ax square plus bx plus c, such that a equals 1, b equals -2 and c equals -8, our vertex 1 -9 equals minus b over 2a and negative d over 4a, where d equals b square minus 4ac. So we have the values of a, b and c. If you substitute those values in this equation, you can directly find the vertex point of the parabola without even graphing it. So, so in the exams or in the paper, you are asked a very short question that you have a polynomial y equals x square minus 2x minus 8 and find the vertex of the parabola. You need not graph or draw the entire parabola for that. You can directly use this equation minus b over 2a and negative d over 4a to find the vertex. In this case, we have vertex -1 and 9. So you can check, you can substitute a, b and c in this equation, you will get this answer. Great. Okay. So I want these problems to do it by yourself. The first one is y equals 3 minus 2x minus x squared. Now here you can see the coefficient of x squared is -1. This is our first observation, right? If the coefficient of x squared is negative, the parabola would open downwards. So you yourself plot this parabola and make the key observations. All right. The second case, y equals x square minus 6x plus 9. You will see that x only has one zero. I mean, it has two zeros, but those two zeros are same. X equals 3. So this means it only has one unique zero, x equals 3. This means that the parabola would cut x-axis only once. And for the third case, y equals 2x squared minus 4x minus 5, you will see that this polynomial does not have any real zeros. That means this polynomial will never cut the x-axis. Okay, so these three cases are completely unique and then they are very good and they can be asked in the exams. So I request you to do it by yourself. So in this video, we did the zeros of the polynomial, how to find zeros of the polynomial, and how do we know without solving that how many zeros will this polynomial have. And then we graphed linear and quadratic polynomial and we made key observations to it. So in the next video, we will be doing the relationship between the zeros and coefficients of the polynomial. This is a very, very important topic. Please stay with me. And this is asked in the exam very, very, very frequently. So thank you so much and see you then.